Hey guys, this is Rev from Into Gaming. Today we're going to dive into some multiplayer interactive action. We're taking a painted foliage asset, we're going to paint some trees, and we're going to essentially chop them down in a multiplayer environment. The base principle here is you have the instances that are painted. Let me paint a few here for you. You have these instances that are painted all around with the foliage tool, and the characters in a multiplayer environment can come up and chop them down. What's basically happening here is we are on interaction. We are removing the painted instance static mesh ISM. We're removing that and having the server spawn a new actor to replace that in its position, and have that new actor is going to topple over like it was chopped. We're going to go ahead and show that to you real quick. Let's do 2-player new windows. And you can see my guys right here. Get up and chop a tree. So we have working code here. There's just the approach that I'm doing is not your normal single player approach, and we're not using multicast and so forth, because we can't rely on the replicated actor to get to every client fast, because there's pings, there's inherited tick delays, and so forth. So we have to work around these inherited delays. And the way that we do this is the server's actor that it spawns. In this case, it's the BP HISM replacement class that I've created. That actor removes the ISM on the local client when it gets replicated over. And that's so you don't have the pop-in that you normally have. So to better explain this, I'm going to pop out a few little assets here. Okay, say we have this tree here. That's my local ISM. Okay, if my client removes it before the server's actually gets there, before the replicated actor gets there, I have a point in time, a duration, where I don't have a tree. Nothing of that tree is being rendered. And then we get the pop-in from the server's replicated actor getting to us, because it has to travel across the internet for us to get that update, for us to spawn it, and so forth. So when the server spawns something, it's telling you, hey, I spawned this actor class. Your local client is actually spawning its own local version of it, and then anything that's replicated from the server's version is that data is passed back. So like if I had variables inside the actor class that were replicated, the server will be replicating just those variables to us. It's not actually replicating the full mesh, the full class. It's just telling it, hey, I spawned this class, you spawn this class, this is where I want you to spawn it, and here's some data that goes along with that. So we're going to have these little pop-in issues because of ping. So if I had 150 ping, that means I have a 75 millisecond delay from server to client, and then client to server. So I'm going to have it, it's going to be poop, I get rid of my local, and then the servers pops in. That's how that works. There's the multicast approach, where we tell the server to run a multicast, which multicast it run on all clients. Every client will run any logic that's chained in that multicast. So if we have a multicast that says, hey, remove an ISM So we're going to have the client do a trace and get the ISM that's in front of it and replace that ISM, or just remove it, and then the server is going to spawn another replicated actor, and that actor is going to come in and take that old position over. Well, the issue you have with that multicast is the multicast itself and the replicated actor are going to arrive at the same time because they get bundled at the start of the next tick and sent. RPCs, input actions, WASD, stuff like that, they don't fire, they don't get sent to the server or server to client immediately. They are all bundled up and processed out at the next tick, the start of next tick. So there's a delay there. But we would get both those things at the same time. So I'd have my tree, my ISM, sitting here, and then the server would it would pop an ISM, its replicated actor over the top of it, and then I'd go try to trace to hit my ISM. I can't hit it. I'm hitting the replicated actor because they both have collision. The tree that gets sent by the server has collision, and that's what would happen. You'd literally bloop, not be able to replace that ISM. So you're going to get a block from the replacement actor coming in and taking the same position, and yeah, no luck there. So the way that we're doing it here in this demo is we are having the actual actor that we're replacing we're moving in. It's going to actually remove the ISM underneath it in its position. So getting into that, let's just jump right into the code on this. So my setup here, it's simple. I'm not doing any kind of crazy animation. I'm just firing off a client-side trace. Notice here that switch has authorities, so this input action doesn't have, the server is not running the same thing. The authoritative proxy on the server is not running this client trace as well. We're actually telling the server to run its own traces through this function. Otherwise, you would end up instances where two trees respond instead of one. So in your setup, you might have an axe or some other item that you're actually animating and swinging in to hit the tree, the rock, the box, crate, whatever, to break it and so forth. But I'm not going to set that all up just for a demonstration. So the key thing here is we want a hit result, and that's what this is going to do. I'm firing from my client's camera. I'm just shooting out a trace. You would do it your way with your axe, hammer, whatever tool that you're going to be swinging. You could generally do an overlap, and when you got that overlap, you would fire a trace off at that overlap location to see if you actually hit. So we get our hit, and we're going to take the hit component here and cast it to an instant static mesh component. And that's going to tell us that, hey, it's an ISM and so forth, so we can proceed. But in general practice here, what you would want to do is get the static mesh here, get the static mesh, and then compare that against a list, a data table or something, or a T-map or some kind of an array, something that you could validate that, hey, this actual mesh, it is an ISM, but is it one that we can interact with? So if I have grass, that's going to be painted into my interaction, and that's what I trace and hit. You don't want grass coming up and being replaced with a tree or some other asset. So you would validate it a little bit further. But for this demo, we just need to make sure that it's an instant static mesh, and then go from there. So I'm taking the world location of that, and I'm passing it to an RPC to the server. Server will replace ISM, and this is the location of the client's instant static mesh, the one that I just traced. I hit a tree. This is the location of that tree on my client. The reason why we're passing this is sometimes, depending on pings, latency, server load, and so forth, where your character gets to at this moment when the server gets that RPC to do its tracing, because the server's going to do its own trace, might vary. The location, so my camera is pointing at a certain direction right now when I fire off. But the server, when it gets this RPC to fire off its own traces, its camera might not be in the perfect position to get that hit, get the same hit. It happens, especially in multiplayer, so you have to do a few extra steps to make sure that you get close enough result. And we're going to jump right to that. So back out here, so we're actually calling this RPC, and we're passing that value to a function server trace and replace. Values on here, I want to make note, any pinned values coming into a function, they're global to the function, so you don't have to run wires, you don't have to do any of that. You can actually just get client location, and you have the variable for it. It won't show up in local, but it's there. You just match the name on your search and you'll find it. So just wanted to note that. So first things first, on here, anything to do with the sign, and when you're passing values to the server from the client, you never trust the client. Never ever trust the client, especially in multiplayer. So rule 1, never trust the client. So we're going to validate the hit. We're going to ensure that the server, the server's copy of your player is actually hitting something, instead of just, hey, well, I'm going to replace some random thing and then spawn something. So this process here, right here with these, we have a line trace, and then we have a sphere trace. These two are going to validate that we're hitting something. So generally what you want to do, your then 0 off of here would be more along the lines of, validating the location of the client to the tree. So for an example, if I take the capsule component, I want to get its world location, get the capsule component of the server's actor, and we're going to go distance, do a distance vector, and we're going to compare that, or we're going to calculate the distance between the client location and the server's capsule component. And what this is basically going to say, it says where the capsule component is, what handles movement of your player, where is it in relation to the ISM that the client side he just hit. And then we got a distance here between these two. And my client ISM, I'm doing its trace. I'm doing a 200 centimeter trace from the camera. And this is a first player perspective. It's FPP camera, so it's right in the head. So 200 centimeters out from that is my max radius for being able to hit something. So I can easily tell the distance here. So if my distance is greater than, I'll say, for margin of error, let's say 250. If the distance is 250, let me do a branch here, then I failed. My client is technically nowhere near the ISM that it claims it hit. So what this would do is we would just instantly return on that, do a return on that function call, and just skip this whole thing out and not proceed with it, because my client's nowhere near it. This right here prevents your client being on one side of the map and saying that it hit a tree or a rock or whatever, a harvest item on the other side of the map. This is a prevention measure for doing that. Also, when they come back to this here, notice that we're only firing this RPC off to the server when the client gets a hit. This prevents spam. This prevents you from swinging your axe in the middle of a field with nothing harvestable around you and spamming RPC calls to the server, eating up your bandwidth and saturating the network. So you want to be cognizant of that. Don't send anything to the server unless you're guaranteed some kind of a result back. Anyway, so we're coming into this, and we're going to fire off a line trace from the server. And let's take a look at that. So I'm going to make sure that the server is the only one that's running this code. We don't want clients running this code. So the server's firing this off, and we're getting the controller, control rotation, forward vector. That's how you get your pitch and yaw. And we're firing this trace from the server's camera, basically the authoritative proxy's camera position of me, or you. So we're actually doing the same type of trace that I did in my beginning when the client trace. It's the same thing, but using the server's proxy. And we're going to see if the server actually hits something. If it hits something, we're going to return it, and we're going to check this off, and we're going to pass the ISM reference, and we're going to pass the hit item index. If it doesn't, if has ISM is not set, if it's false, we're going to come down and we're going to actually do a sphere trace based off the client's location. So obviously up here in this little chunk of code, if we're going to be nitty-gritty about it, this should be then 0, and then we should run off of that, so and so forth, so we can process further. So we're assuming now that the client location is trusted when we're running this. So we're running this sphere trace, we pass in that client location. Now we're going to take the client location and we're going to split it so we have X, Y, and Z, and we're going to modify that sphere. So the base location is going to be on the ground, so we're just moving it up a little bit off the Z, about 600 centimeters, because we are a tree and we want to get up near the fattest part of the tree. And if we look back at the trees, fattest part's right up in here, so we're going to try and do our trace around what we would expect to be hitting around in here. So let's get back into that. So we're doing a 50 centimeter radius sphere trace off of that single, it's not multi, and then casting it and so forth, and then again, I mean, you might want to validate that you're hitting your setup. ISM reference and the hit index that it got. This is all server side. So now we have these variables set. If we have them set, so if we did get a trace here, came out true, we're setting these values. Otherwise we come to the sphere trace and then we're setting these values if we get a result. Otherwise they are null, so you can check this. By default it's null, there's nothing here, and then we can run and it is valid on that. If the ISM reference is valid, then we're going to get the instance transform, we're going to set that as a local, and then we're going to remove the instance from the server's map. And with that, the reason why we set the transform here is because once you remove it, you're not going to be able to get it. So go ahead and set your transform there. Remove the instance, and then we're going to spawn it, and we're going to use that transform value to spawn the location, the spawn location. You split you can break the pin for the transform here. And just pass these values back, and I'm passing the ISM location here where the server spawned it. I'm passing it as a replicated variable on that, and I'll show you that real quick. See, I have ISM location, it's instance settable and exposed on spawn, and it is replicated. So, and that's pretty much it. I mean, we're spawning it off, and it's going to be replicated out. Notice there's no multicast here. Now, so we've spawned this, and it's being replicated out to clients. Excuse me. Once it gets to clients, we have an event begin play. So the server said, hey, I spawned this HISM replacement class. The client spawns a copy of that class at the location that it's supposed to spawn it, and rotation and scale and so forth, and it's got the variable and everything. It's going to hit the event begin play. We're going to validate that this is not going to run on the server. So is not the server, is not a dedicated server. We're going to run this following code. The tree top and the tree trunk, we're going to disable collision on it. And we'll take a look at this real quick. So we have the tree top. This is the aspect of mine that has the physics. And then we have the tree trunk, which no physics on this one. Tree top is the only thing that's going to move. So we're disabling the collision on this so that we can remove the local client's ISM. And removing the ISM is right here. We're going to do a sequence. We're going to take the ISM location that was replicated to us. We're going to add 1,000 centimeters to the Z and set a start vector. And then we're going to subtract 2,000 from the Z for an end vector. And that's going to give us our start and our end for a sphere trace. So we're going to go from the ground, we're going to jump up 1,000 centimeters, and then we're going to fire a sphere trace down 2,000 centimeters. So we're going to make sure that we're shooting down far enough that we could actually hit the ISM on the client. We have a 50 centimeter radius. That's big enough. If it's not hitting on that, it doesn't deserve to be removed. And then we go from there. We're going to verify that the hit component that we get is a instance static mesh. We're going to set a local for giggles, just in case you want to use it for something else. We're going to set a local for the hit index, and then we're going to remove the instance, and then we're going to call initialize tree. Initialize tree. Now that our instance is gone, the ISM is gone, we're going to take the tree trunk and we're going to enable its collision, query, and physics, so we get the proper physics interaction with the tree top that's running physics. We're going to enable the collision to query and physics for the tree top, and then we're going to set this simulate physics. We're going to turn on the physics for the tree top, and that's going to allow it to fall. And that's pretty much it. I have some sleep stuff over here. So on component sleep for the tree, we're going to disable the physics and change the collision to no physics, and then disable tick on the actor. So there's no more movement, and we don't want it to interact after that. So it's pretty straightforward, and obviously you've seen the results. I'm going to run through it real quick. Make sure I didn't miss anything here. So I'm getting a chopped tree, and I'm getting a chopped tree. Alright, the only other thing that I can think of doing, advanced settings, is getting in there, multiplayer options, network emulation, min, max 50. So we're going to emulate some physics real quick. Set, yes. I mean, we're going to emulate some latency, so there should be some delays. You start seeing some real world delay action here. You can see there's obviously some delay, so we're going to have that delay with the server as well. Say I hit it, I'm going to call it out when I hit interaction here. Hit. And you notice that there's no popping. My instance isn't being removed and leaving a null space for rendering. And let's see what this other client is seeing. I'm going to get over here. Hit. And it's seeing it pretty good. Ooh, I got teleported back. See? Packet loss. Emulating packet loss. So, I mean, it's just real world kind of thing that you have to go through. And see, and there we had an issue with the packet loss. And you're going to get them. There's nothing you can get away from. So overall, this is looking pretty good. And you see the packet loss that is popping off. You got some weirdness there. Oh, let's change and hop over to this guy. Hit. So you can see there's a delay in it firing. Hit. And hit. Hit. Yeah, there's a substantial delay there. Hit. So, recommendation is to, for multiplayer, is to run some emulations with 500 ping, 300 ping. So you get a better idea of what's going to happen in your game setup. But if we were doing a multicast on here, you would definitely see where a multicast setup where we removed locally on input. Hey, we're going to go ahead and remove this, and then, yeah, the multicast fires off and it tells us to remove it, or we remove it locally. We'd have some weird issues where we'd have popping, where our local instance is gone and there's a duration of time where we don't have a tree, and then the server's tree gets there and it pops in. So doing it this way, I find is pretty good approach. I'm gonna go ahead and turn this off. I'll turn that off real quick. Get back in there. And I'll do one more run through the code. So this is my default setup. Input key, switch as authority. We're going to call the client trace. The client trace is right here so you can see it. Let me move some of this stuff out of the way. Client trace runs through. If our cast works, it's successful, we're going to pass the world location of that ISM to a server RPC. And you notice here that it is set to reliable and run on server. So this is going to run this function here, calls a line trace, which is this guy right here. And we have our line trace. You can see when this returns. We run our line trace there. If that fails, we're going to do a sphere trace from the client location. So get client location, or get client location, and we're going to split that. The other way to do it, and you can break it and do it that way. We got our client location, doing an offset, so we're moving it from the ground, we're moving it up into the air a little bit and then popping it. And we have the same as the line trace. We're going to cast, if there's a hit result, we're going to cast off of it and then return the proper values. Once we get down to that, we're on then 1. We're going to validate, make sure that the reference that we set, if it's set, basically we're checking if it's set. If it has a value other than none, null. If it does have a value, we're going to get the instance transform from it. We're going to set that as a local, and then we're going to remove the instance, and then we're going to spawn our actor. Our actor is going to come in. I'm not running this on the server to make sure that that is set. We're going to disable the collision on the tree top. We're going to disable the collision on the tree trunk, and then we're going to call remove ISM. Remove ISM. It's going to run a sequence. We're taking the ISM location. We're padding the Z with 1,000 centimeters to create a start for our trace, and then we're going to deduct 2,000 centimeters from the ISM location for a end location. And then we're going to execute a sphere trace from basically above the tree down through the ground and see if we can't pick up the tree itself. We're going to take that result, validate that it is a static, instant static mesh. We're going to set a local and a local ISM reference and then a local hit index. And then we're going to remove the instance, and then we're going to call an event initialize tree. Initialize tree just turns on the collision query in physics for the tree trunk, the tree top, and then it turns on the physics for the tree top. And that's pretty much it. You don't need any of this, but I'll show you what I'm doing down here. So that's pretty much it. Hope it was educational, answered some questions, and gave you some more insights into multiplayer interaction. This stuff has to run and be identical on all clients, especially like these treetops. They have a lot of collision there, and there's blockage. So if I'm hiding behind it, on my screen, I want to be hidden on all other clients' screens that are coming in this, looking in this direction. So, so cognizant of that stuff. And we notice there's no lag, hit, and it's just instant now because there's no ping. We're running 0 ping. Where's my other guy? There he is. So, any questions, hit me up in the comments. Have a good one.